Okay, so today we're going over section 2.4, which is polynomial and rational function. And we're gonna go over like the basics about polynomial and about rational function. So polynomial function, it's a function which looks like this. We have number x with exponent, so these are terms, plus another number x with exponent, plus so on, and continue all the way to x with exponent 0. And n is it's a non-negative integer. It's called the degree of the polynomial. So the highest exponent for n, it's called the highest exponent for x, which is n. It's called the degree of the polynomial. And the coefficients, the numbers in front of the x's are real numbers. And the polynomial, the domain of polynomial function is the set of all real numbers. So if you remember, when you talk about quadratic function, the domain of quadratic function is also all real numbers, because quadratic function is also a polynomial function. So polynomial functions are a class of functions which include linear function, quadratic function, and functions with higher exponent. Okay, so these are polynomial which include quadratic and linear. And also the numbers, you can look at the numbers like a polynomial function also. So here what you need to remember, that domain is always negative infinity, infinity, all real numbers. Okay, so that's the polynomial function. We're going to do examples, we're going to find domain, we're going to find the x-intercept, y-intercept, and everything. The next function we're going to talk about today is a rational function. The rational function, it's a fraction. Looks like this. Polynomial over polynomial. See, n and d, numerator and denominator, are polynomials. So the rational function, it's a fraction, something over something. Now the domain here is not all real numbers because you have a fraction. The denominator of the fraction is not 0. That's how you find the domain. So the domain is everything but whatever the denominator is 0. So if I need to find the domain, in order to find it, I need to set the denominator, whatever is in the bottom. So take everything in the bottom and solve it not equal 0. These are your restrictions. Okay? So you have restrictions in the domain. It's not all real numbers, you have restrictions. The bottom cannot be 0. That's the restriction for fraction. And then rational functions have also vertical and horizontal asymptotes. What that means? Now, the graph of polynomial function, it's a smooth curve. I'm going to just give you an idea how the graph looks like. And I'm just going to draw like graphs. So the graph of polynomial, if you remember, quadratic was parabola, open upside down or down up, depends. So in general, the polynomial function, it's a curve going up and down, something like that. Okay, depends what is the degree of the polynomial. So polynomial function, it's a smooth curve going up and down. The rational function, in other hand, have restrictions. So because of the restrictions, the graph is going to look, so they're going to be a vertical asymptote. So the vertical asymptotes are the places where there is no graph, and the vertical asymptote looks like vertical lines. Could be one, could be two vertical lines, depends how the denominator looks like, depends how many restrictions you have. So if you have one restriction from the domain, they're going to be one vertical asymptote. If there are two restrictions in the domain, then they're going to be two vertical asymptotes. So the vertical asymptote, I'm going to put VA, vertical asymptote, are vertical lines, and you get those from the restrictions from the domain. And they just explain how to find it. Suppose the numerator and denominator have no real zero. And in this case, whatever is the zero of the denominator, that's your vertical asymptote. And if they have one or more real zero in common, then you're going to cancel them and you're going to reduce it. And in that point, whatever is the common zero, they're going to be a whole. I'm going to explain that on the graph. Okay, so they're going to be a whole wherever the common factor cancel up and down. And I'm going to go over that in detail later on. We're going to do examples. So how the graph looks like if you have a vertical asymptote. So the graph is going to look something like this. It could be like this. So it's going to be two pieces, one piece in one side, and let's say another piece in this side. Okay, and also you're going to have horizontal asymptote. So horizontal asymptote, we have different cases here, and the horizontal asymptote is connected with the degree of the polynomial. So I'm going to go over these three cases, and in the graph I have right now, this is going to be horizontal asymptote. It's going to be the place where so pretty much the horizontal and the vertical asymptotes. So this is vertical asymptote. I'm sorry, horizontal. So horizontal and vertical asymptote, this horizontal or vertical lines where the graph is going close to, but you never cross it. So see, the graph is going close to the vertical asymptote, so it's going close, but you never cross the vertical asymptote, okay? The same way, the graph is going very close to the horizontal, but you don't cross it. So that's the idea about horizontal and vertical asymptotes. And for horizontal, there are three cases when you compare the degree up and the degree down in the polynomials, in the fraction. And we're going to do examples to see how we're going to find all these different cases. Okay, so that's how you, we're going to analyze that in a little bit. So any questions so far? Okay, so then you're going to go this. We're going to, for number 1 to 6, there's 6 examples. We're going to find, for these are polynomial functions. We're going to have 6 polynomial functions given from 1 to 6. We need to find the degree of the polynomial. We're going to find the X-intercept and the Y-intercept. Okay? And let's start with number 1, for example. Okay. So, looking at my example 1. So, we have, this is my polynomial function, and then equals, they factor it. So, when you factor it, it's going to look like this. And it's really easy because they give us the factor form, because the factor form is going to help us to find the X-intercept. Because now looking at your first form, like the one with expanded with x cubed and 2x squared minus 23x minus 60, looking at this equation, what is the degree? Can you tell me what is the degree of the polynomial? What is the highest exponent?
3.
The degree is 3, that's right, because it's the highest exponent. Also, if you have given only the factor form, you're going to see how many factors with x you have. You have 1x, 2x, 3x. So when you multiply x 3 times, it's going to be x cubed. So that tells you the degree of the polynomial is 3. That's all. Then we have to find the x-intercepts. Finding the x-intercept is the same rule we use for quadratic function. And I'm going to write the rule here. For x-intercept, you're going to solve f of, I'm going to write it actually. You're going to solve the function equals 0. F of x equals 0. Solve that equation. So for x-intercept here in number 1, I have to solve x cubed plus 2x squared minus 23x minus 60 equals 0. Now this equation is exponent 3. So in order to solve it, it's easier if I use the factor form. If I have x plus 3, x minus 5, and x plus 4 equals 0. this is going to solve faster because it's already factored, and I'll show you how to solve it. Now, when you find the y-intercept, you need to plug it in. X is 0, so I have to do what is f of 0. That's your y-intercept. Okay, so let's do x-intercept first. So finding the x-intercept is looking at the factor form of the polynomial, solve it equals 0, and solving equals 0 using zero product property. So you have something times something times something equals 0. So in this case, you're going to solve each of the factors equals 0. And that's how you're going to get 3 solutions. So if the degree is 3, they're going to be 3x intercept. If the degree is 5, they're going to be 5x intercept. Maximum, that's the rule pretty much. So I need to solve x plus 3 equals 0. I need to solve x minus 5 equals 0. And I need to solve x plus 4 equals 0. That's going to give me 3x intercepts. So the first one, I'm going to subtract 3 in both sides. And my first x intercept is going to be x equals -3. The other one is going to be, I'm going to add 5 in both sides. And the second x intercept is going to be x equals 5. So I'm going to cross the x-axis at -3 at 5. And the last one, you're going to subtract 4. And you're going to get x equals -4. So these are the 3x intercept. How you write them? We're going to write -3, 0. That's the point. -3, 0. 5, 0. And -4, 0. So these are the 3x intercepts, okay? And then we're going to find the y-intercept. So finding the y-intercept, I need to plug it in 0 for x, right? Now, you can plug in both of those, but it's easier if you use the first form. If you plug it in here, so it's going to be 0 cubed plus 2 0 square minus 23, 23 x is going to be 0 minus 60. Why it's easier this way? Because everywhere you have x is going to be 0, 0, 0, right? And the answer is -60 is left. So my y-intercept, the point on the y-axis where you're going to cross the y-axis is going to be, the point is 0, -60. Okay? Everybody understanding this? Any questions? Let me know. So that's what you need to do for polynomial. It's pretty simple, right? You want to do another one? Question? Do you guys have any questions?
No, ma'am.
No?
No.
Everybody understand this? Okay, you want to do another example? So these are the answers for. Okay, you guys want to do another example? Okay, you want to do one more? Or you got it?
One more.
One more. Okay, so all these are the same. So all of these are pretty much x3, x3. I'm going to do x4 and x5. Let's do one of those. Okay, so we're going to do 5, 4, 6. Which one you want to do?
6.
6.
Okay, let's do 6. Okay, so we are going to do 6. So we're going to start the same way. What is the degree?
5.
The degree is 5 because the highest exponent for x is 5. Now let's find the x-intercepts. For x-intercept, we're going to use this form, right? The factor form. So we need to solve x plus 3 times x minus 1, x plus 1, and x squared plus 2x minus 5 equals 0, right? And in order to solve this, we're gonna solve each of the factors 0. X plus 3, 0, x minus 1, 0, x plus 1, and this one also, right? So I'm going to solve each of those 0. And obviously you notice that if I solve x plus 3 equals 0, what is x equals? Opposite. Negative
3.
Okay. The next one is going to be x equals, opposite of negative 1 is 1. The next one is going to be x equals, opposite of 1 is negative 1. And then we're going to try to solve x squared plus 2x minus 5 equals 0. Obviously, this equation is not factorable because if it's factorable, they should factor it already, right? So in order to solve this, we're going to try using the quadratic formula, okay? Because sometimes you can have not a whole number. It could be a decimal number solution, okay? Or irrational. So let's see. We're going to solve it. We're going to use the quadratic formula. So I'm going to start with ABC. So what is A? A is 1, B is 2, and C is negative 5. We're going to plug those into the quadratic formula. So x is going to be the quadratic formula negative b plus or minus b squared is 2 times 2 is 4 minus 4a and c averaging over 2a, 2 times 1. Okay, now here what is the square root? So when you multiply negative 4 times negative, it's 20 plus 4 is 24. So far we have negative 2 plus or minus square root of 24 over 2. Now square root of 24 is not perfect square, right? So in order to simplify this, we're going to break down 24 is what? 6 times 4 is 24, right? So I'm going to write it here. 24, it's 4 times 6. And you can, because you're taking square root, it's going to be square root of 4, square root of 6. And square root of 4 is actually 2. So square root of 24 is going to be 2 square root of 6. That's how you break it down. You take it out. So I'm going to simplify that, and I'm going to get x equals, I'm going to write it here, negative 2 plus or minus 2 square root of 6 averaging over 2. Now this averaging over 2, I can actually split it. I can put this over 2 and this over 2. So that way you can reduce it. So negative 2 and 2 cancel, so it's going to be negative 1, and these 2 cancel, so my x intercepts are going to be negative 1 plus or minus square root of 6. So these are actually 2 x intercepts, negative 1 plus square root of 6 and negative 1 minus square root of 6. Okay? So your final answers for x intercepts are going to be, I'm going to list them here. So they're going to be negative 3, 0, 1, 0, negative 1 and 0. And then I have 2 more here. And they're going to be negative 1 plus square root of 6 and 0. And negative 1 minus square root of 6, comma 0. Because you're not graphing, that's why you can just list them like this. If you need to graph, then you can just round to the nearest number. So these are the 5 x intercepts we got. The degree is 5, and then 5 x intercepts. Okay, any questions so far?
No, ma'am.
No? Okay, I'm going to just take a little note here. If you get square root of negative, here, if instead of 24, it's a negative number, then it's going to be no x-intercept. This term, this factor is not going to give x-intercept. So if this is negative, oops, what's happened? Really, what's happened now? Okay, I'm going to fix it. Okay, so here we have if, so the note is if inside the square root is what 24, right? So if the inside of the square root is a negative number, if it is negative, then it's going to be no X intercept. This term is going to give you no X intercept. Okay? But in this case, it's positive, so it's going to give you X intercept. Because if it's negative number, inside the square root, it's a complex number, imaginary number. So the imaginary numbers, you don't graph them on the graph. So that's why if the square root is negative, this term, we're talking about this term, is not going to give you X intercept, but you're still going to have the other three. Okay? So that's how you do that. And we have one more thing to find. We have to find the Y-intercept. So how you find the Y-intercept? I'm going to put it here. So finding the Y-intercept is plug it in X, 0. And in that case, it's easier to use the first form. So using this form, so it's going to be 0 to the 5th plus 5, 0 to the 4th minus 20, 0 squared minus 0 plus 15. And obviously all of these zeros, they're gonna just disappear. I just put it there so you know what you're doing. And this is my Y-intercept. You're crossing the Y-axis at 15. So the Y-intercept is gonna be 0, 15. Okay? That's the answer for the Y-intercept. Any questions so far? Okay, so that's how you do, that's how you find the X-intercept, the Y-intercept, and the degree for the polynomial function. Okay, so that concludes pretty much the idea about polynomial function. Now the next step is going over the rational function. And I'll be back to number 1 to go over the steps we have to do. Or actually, they're going to give us the steps down here. Okay, so these are the steps. For the given functions, so I have few functions given here. We have to find the domain, and you find in the domain, I'm going to put the notes here, finding the domain is we have to solve the denominator not equal 0. So the rational function looks like numerator over denominator, right? That's the rational function. And I'm going to say f of x is this. Okay? Numerator over denominator. So finding the domain, solving the denominator not equal 0. Finding the x-intercept is going to be solving the function equal 0, which is solving actually the numerator equals 0, the top equals 0 only. Finding the y-intercept is plug it in 0, f of 0. That's how you do it. Finding the vertical asymptote is from the domain. So the vertical asymptote, you're going to get it from the domain. It's going to be denominator equals 0. See, the domain is not equal. For the asymptote, it's equal 0. That's going to give you the equation. And the horizontal asymptote, there are 3 cases. I'm going to go over that. 3 cases. And then sketch the graph. You're going to graph it. And when you graph, you're just going to do all the steps. You're going to put everything on the graph. Okay, so now let's start with, let me explain the 3 cases. So first, you're going to compare the highest exponent up and the highest exponent down. Okay, so I'm going to just write it here just in case to understand what's going on. So if the numerator has, looks like this, number x, and because I have n, I'm going to use p and q plus something else. So that's the highest term, the first term in the top, and in the bottom it's b, x, q plus on. Okay, so that's why I know that the highest exponent up is p, the highest exponent down is q. That's what I need. So the first case is going to be when p is smaller than q. That means the exponent up is smaller than the exponent down. And that's exactly what you have in this one. And I'm going to just put example here. So for example, if I have let's say if my function is 2x minus 1 over x squared plus 5, for example. See, the exponent up is 1, the exponent down is 2. So that's the case when the exponent up is smaller than exponent down. So if this is the case, if the exponent up is smaller, then the horizontal asymptote is going to be y equals 0. Always, y equals 0. That's your horizontal asymptote. Then the second case is going to be when they're equals, when p equals q, which means if you have exponent x up, exponent x down, that's at the highest, or x squared up, x squared down, they're the same. So in that case, the horizontal asymptote is going to be y equals a over b. A is the number in front of x, the highest exponent, and b is the number in front of the highest. That's the horizontal asymptote. A and b are numbers. Keep that in mind. Then after that, if I want to, there's one more case, which is if p is bigger than q, which means the exponent up is bigger than the exponent down. For example, if I have, let's say, x cubed minus 2x plus 1, for example, in the top, the highest is 3, right? And in the bottom is smaller. So let's say the bottom is x minus 5. See, this is first, right? Exponent up is bigger than the exponent down. In this case, if this is the case, then there are no horizontal asymptotes. Okay, so this is how you know how you determine the horizontal asymptote. Okay, so these are the three cases, and the same three cases I explain over here. If the degree at the top is smaller, then y equals 0 is the horizontal asymptote, right? If the degree are equals, y equals a over b is the horizontal, right? And if the top is bigger than the bottom, then no horizontal asymptote, okay? So that's exactly what you have here. So these are the three cases for horizontal asymptote. And now let's go ahead and start doing some examples. So you'll see exactly what you're talking about. Okay, so I'm going to start with number 7 is the first one. And you're going to do all these steps. You're going to find domain, you're going to find everything. The X-intercept, Y-intercept, horizontal, vertical, and you're going to graph it. Okay, so let's start with domain. So first finding the domain. So the domain, I'm going to take the bottom, which is 2x, and solve it not equal 0, right? How you solve that? You're going to divide by 2, and that's going to be x is not equal 0. So the domain is x not equal 0. That's it. X is not 0. That's the domain. You can write it like that, or you can write negative infinity, 0, 0, infinity. Okay, depends how they want the domain. You'll see that in the lab. Okay, the next step is finding the X-intercept. X-intercept, you're going to solve the top equals 0, the numerator equals 0. So the top is 1 equals 0. Is that half solution? 1 is not 0, right? 1 doesn't have x, so that means there's not going to be solution for this equation. So if this equation have no solution, there is no x, that means there are no X-intercepts, which is okay. Remember with the graph of quadratic, there was also case when you don't cross the x-axis, which is okay. Then the next step is going to the Y-intercept. And for the y-intercept, we're gonna plug it in the whole function 0. So my function, I'm gonna put f of 0. I'm gonna copy the whole function 1 over 2 times 0. What is that? 1 over 0, it's undefined, right? And also, if you see the domain x cannot be 0, so you can plug 0 technically, right? This is undefined, so that means there are no y-intercept also. You don't cross the y-axis. Okay? And then we're gonna go to find the vertical asymptote is the next step. Vertical asymptote, you get it from the domain. But instead of not equal, you're gonna have equal. So vertical asymptote is gonna be x equals 0. You get that from the domain. See, the domain is x is not 0. Vertical is gonna be x equals 0. The same like the domain, but equal, not equal. And then the next step is finding the horizontal asymptote. Now we need to see which case we are. Which one of those cases? So what is p? What is the highest exponent up? There is no x in the top, right? Looking at my function 1 over 2x, there is no x in the top. But I can just put invisible x to the 0 here, right? If it's only a number, it could be x to the 0. What is x to the 0? X to the 0 is 1, right? So 1 times 1, I mean, x to the 0 is technically 1. So if it's only a number, then the exponent up is 0. What is the exponent down? So in the top you have x to the 0, or let's write it like that. So the top is x to the 0. What is the bottom? X to the first, right? So which case we are? The first, the second, or the third case?
Is it the first one?
The first case. Good job. We have the first case. Because the highest exponent up is smaller than the exponent down. So if it's the first case, automatically I know what is my horizontal asymptote. It's going to be y equals 0. That's my asymptote. Now, when you write the asymptote, make sure you write it like equation. X equals 0, y equals 0, or x equals something, y equals something. It's equation of a line because the asymptotes are horizontal or vertical line. So you have to write them like equation of line. Okay? So we have all the steps here. Now we just have to graph the function. And it says from negative 10 to 10. So, okay, I have enough room. So I'm going to just draw a little x-axis, y-axis, and I'm going to graph it. Okay, so we have domain is x is not 0, no x-intercept. There's not too many things to put here, right? Okay, so no x-intercept, so you don't have points on the x-axis, no points in the y-axis. What else we have? We have given vertical asymptote at 0, right? X is 0. So that means my vertical asymptote is going to be the y-axis because that's the line. I'm going to put it a little off the y-axis so it's obvious. So this is my vertical asymptote. So that means the graph is going to go close to the y-axis, but you're never going to cross the y-axis. The same way with the horizontal. Y equals 0 is the equation of the x-axis. So that's my horizontal asymptote. So that means my graph is going to be not crossing the x-axis, not crossing the y-axis, obviously, because if you have no x-intercept and y-intercept, you're not crossing them, right? So now, where's the graph? There are going to be two pieces of the graph. That's where you start. You start with how many pieces you're going to have. You're going to have two pieces. You're going to have one graph in the left of the horizontal and one graph of the right of the vertical, sorry. We're looking always at the vertical asymptotes. So one piece in the left, one piece in the right of the vertical. Now, where's the graph? It could be up like this, or it could be down like this, okay? One of those. Which one? In this case, we're not sure if it's up or down. So in this case, you have to pick a point. we're gonna pick a number, let's say -1 here, and I'm gonna plug this x -1 into the function and see if it's positive or negative. So I'm gonna take a point, f of -1. It's like a checkpoint to see if it's above or below. So I'm gonna replace x with -1 into the function. So it's gonna be 1/2 times -1 is gonna be -1/2, right? -1/2, it's below, right? So that tells me that the graph is gonna go like this. Okay? I mean, not quite like this, but I'm gonna go through -1 and -1/2. So this is gonna be the point where it's gonna go. So in that way, when I pick a checkpoint, I'm gonna have 1 point on the graph. X is -1, Y is -1/2, right? So this is the point. And then the graph is gonna go close to the horizontal, you never cross it. And then you're gonna go close to the vertical and you never cross it. So that's the one piece of the graph. Then you're gonna look on the other side of the vertical asymptote. So the graph could be like this or like this, one of those. Again, we don't know where. So we're gonna pick another point. And we can pick in this side of 0, right? You can pick 1, 2, whatever you want. I'm gonna pick 1. And again, I'm gonna plug it in. So I'm gonna find what is f of 1. So I'm gonna replace x with 1. So it's gonna be 2 times 1 is 1/2, okay? So it's a positive, so that tells me it's not below, it's above the graph because y is positive. And the point we have here, the point the graph is gonna cross to is 1 and 1/2. And we're gonna graph that. Oops. So the point is 1 and 1/2. So if this is 1 and 1/2 is somewhere here, right? So the graph is gonna go close to the horizontal. It's gonna go close to the vertical. And that's my graph. Okay? Any questions? Everybody understand that? Okay, let's do another one. You guys ready for another one? Okay, let's do number 8. Okay, let's do number 8. Okay, so number 8, we're gonna start with domain first, right? We're gonna start domain. And domain, you're taking the bottom equals 0. Not equal, actually. Not equal 0. You're gonna add 4 in both sides. And it's gonna be x not equal 4. So that's the domain. X is not equal 4. This is my domain. Everything else but 4. Okay, then after that, we're gonna find the X intercept and the Y intercept. For X intercept, you're gonna solve the top equals 0. So you're gonna solve 4x equals 0. You're gonna divide by 4. And the X intercept is gonna be x equals 0. So the point, the graph is gonna go to 0, 0. Okay, that's my X intercept, 0, 0. Then you're gonna do the Y intercept. So Y-intercept, you're going to plug it in 0. So it's going to be f of 0, everything. So it's going to be 4, 0 over 0 minus 4. And that's 0 over -4, which is 0, right? So my Y-intercept is going to be the same, 0, 0. And it's always if you cross in x-axis at 0, you're going to cross the y-axis at 0 also, right? Always, if one of those is 0, 0, the other one is the same. Okay, then after that, we have to find vertical asymptote. Okay, it's doing it again. Okay. So we're gonna find, let me save it what I have so far. Okay, so we'll do number 8. Okay, let's see. Am I writing too fast or what's going on? Yeah, probably I'm writing too fast and the computer is not. Okay, so I'm gonna fix this to look better. Okay, so the domain is not equal 0. X intercept is 0, 0, Y intercept 0, 0. Okay, and we're gonna continue from there. This is -4. Okay, looks better. Okay, so the next one we're gonna continue is vertical asymptote. And the vertical asymptote, we're gonna find it from the domain. Domain is X is not equal 4, the vertical is gonna be X equals 4. That's it. Then after that, we have to find the horizontal asymptote. And the horizontal asymptote is, we need to see what is the case. So in this case, the top highest exponent is 1 and the bottom is 1, right? 1 over 1. So they're the same. So that's which case? Case number 2. So we have case 2. And in this case, the horizontal asymptote is going to be y equals, we need to get what are the coefficients in front of the x's. The highest x, the top x is 4 in front, and the bottom x is 1 in front. So it's going to be 4 over 1, which is 4. Everybody understand that? So we're getting the coefficients in front of the x's, up and down. Okay? So that's it. That's how you get all the steps you need to graph the function. So I have the domain, the x-intercept, the y-intercept, vertical and horizontal asymptote, and now we have to graph it. So how you graph it? We're going to start with x-axis and y-axis, right? The same way. And then, hold on, we have x is 4, so I'm going to move this a little bit this way. Okay, so we have x-axis and y-axis. This is what is given. We're going to start with the asymptotes. Okay, so we have x equals 4. So this is my vertical asymptote. So the graph is going to go close to this vertical asymptote. And then I have horizontal at y equals 4. So I have 1, 2, 3, 4. This is my horizontal asymptote. Okay, then I have a point, which is 0, 0. So the graph is going to go through 0, 0. Okay, now we're going to start with, we have one vertical asymptote, so we're going to have one graph in this side and one graph in that side, yes? So looking at my left side of the vertical asymptote, the graph could be above the horizontal or below the horizontal, where it is. Obviously, it's below because there is a point. Everybody understand that? The graph has to go through that point. So it's going to go close to the horizontal, close to the vertical. This is the graph. Then after that, I need to look at the other side. So looking at your right side of the vertical, we can have graph above or we can have graph below. Which one of those it is? Is it above or below? What do you think?
Above.
It's above. Good job. It's above because if it's below, you have to cross the x-axis, but there is no other x-intercept. So it's going to be above. Because if it's above, it's going to go close to the horizontal. So that means it's not going to go below 4. So it's not going to cross the x-axis. and it's going to go close to the vertical asymptote also. Okay, so this is my graph. So in this case, we don't need to get extra points to check. Okay, to check if it's where it's exactly the graph. So everybody understanding the concept? You want another one or you got it?
We do another one?
Yes, let's do another one. Okay, so we have, let's see, we have number 9 is the same idea. It's the same second case when you have the top and the bottom are the same. Let's see if you have different. This is the same, X and X up and down, so it's the same. And this is another one with X and X in the top. This is another one with X and X. Let's see if you have something different. Okay, let's do this one. Let's do this one. It's a negative and have more numbers. So let's do this one, number 12. Okay, so let's start again with finding the domain. So what is the domain? I'm going to start with the bottom. 1 plus 2x equals 0. You're going to subtract 1 in both sides. We're solving linear equation. So 2x equals -1. Divide by 2 both sides. Or actually start with not equal, right? Domain is x is, the denominator is not equal. So my domain is going to be x is not equal -1 over 2. So that means x can be everything but -1/2. Okay, that's the domain. Then after that, we're going to go ahead and do the x-intercepts. So finding the x-intercept, you're solving the top equals 0. 1 minus 5x equals 0. So what you're doing, you're going to add 5x. You're going to move 5x over. And you get 1 equals 5x. Divide by 5. So x equals 1 over 5. And that's my x-intercept. X is 1 over 5, comma 0. 1 over 5 is technically 0.2. But you can just leave it like that. So we have one x-intercept. Then let's go ahead and find the y-intercept. Y-intercept, you're doing f of 0. So we're going to plug it in, everything 0. So you have 1 minus 5 times 0 over 1 plus 2 times 0. So this is 0, this is 0, so you get 1 over 1 is 1. So the y-intercept is going to be 0 and 1. That's the point where you're going to cross the y-axis. Okay? Then after that, we have to go ahead and find the asymptotes. So we need to find the, let's find the vertical asymptote first. Vertical asymptote is from domain. So domain is x is not. So in this case, the vertical is going to be x is equal to -1/2. And then we're going to find the horizontal asymptote. Now, what is the case? First, second, or third? See, the highest exponent is x, x to the first, and the bottom is x to the first. So that's case 2, right? And case 2 says y equals a over b. So here we have to look at the numbers in front of x in the top and in front of x in the bottom. So if you have that, it's going to be y equals -5 over 2. That's my horizontal asymptote. Okay, any questions? And then we have to put everything on the graph and graph it. So we're going to start with x-axis, y-axis. I'm going to do it here. Okay, So let's put the asymptotes first. So we have vertical x is negative 1/2 is here. So this is my vertical. Horizontal -5/2, which is 2.5, right? Negative. So this is horizontal asymptote. Then you have, this is your vertical asymptote. And let's put the points. We have X intercepted. The X intercept is 150, which is 0.2. And the other one is the Y-intercept is 0 and 1. So going through these 2 points, okay? So now we have to look at your vertical asymptote. You have to do to the left and to the right. So to the right, obviously the graph is going to go through these 2 points, so it's going to be above the horizontal, right? So it's going to go close to the horizontal and then close to the vertical, and you never cross the horizontal and the vertical. So this is how the shape is going to look like. And then the other side, obviously it's not going to be above, it's going to be below, over here, below the asymptote, because if it's above, you're going to cross the x-axis, but there's no another x-intercept. Make sense? So this is how the graph looks like. Okay, any questions? Everybody understanding this?
Yes.
Yes.
Yes, ma'am.
Okay. Okay, so here we have on your homework question where they ask me the graph of the right, to the right is the graph of polynomial function. So I show you how the graph looks like. It's a smooth curve, right? First, you need to find the minimum degree of the polynomial. So how you find the minimum degree? What you need to do here to find the minimum degree, you have to see how many turning points you have. And turning points are points like this. So the graph is going up and then it's going down. There's another turning point down here because the graph is going down and then it's turning up. And there is one more here, right? So if you have 3 turning points, that means the degree is going to be 4. One more. It's always one more. So the answer here I'm going to put is 4. That's the answer. Okay, and then the next one is asking, is the leading coefficient positive or negative? So this is something like we did in quadratic. So if the graph is going down, see the graph is continued down both ways, then it's going to be negative. If it's going up both ways, the leading coefficient is going to be positive. So the same idea. Okay, so in this case, it's going to be negative. You got it? Okay, so that was the one here. Let's see what else. What is the maximum number of x-intercept? We talk about that. If the degree is 6, how many x-intercept are there? Maximum 6, right? The same. So the x-intercept is the same number like a degree. Turning point is one number less. Make sense? Then the next one is, this is the equation, find the horizontal. So we did that, the horizontal asymptote. You compare the exponent up, the exponent down, okay? You know that. Okay, we did that. Horizontal asymptote, we did that also. Vertical asymptote, we did that. You solve the bottom equals 0 and find the asymptotes. Okay, so this is where they're talking about the cost function. Okay, so let's talk about the cost function. A company is planning to manufacture snowboards. This is, we did this before when you have fixed cost and variable cost. So the cost function is the fixed cost plus So I need to find the equation for the cost function. So here we have the total cost is a linear. Okay. The fixed costs are 400 per day. So if it's per day, this is actually variable cost. And this is the total cost per day at a daily output of 20. Also, this is given information and you have to find. Okay, so if it's linear, so the function, cost function is going to be mx plus b, right? I'm going to use this. M is fixed cost. So it says fixed cost. So it's going to be 400 is the fix. And also we need to find the swap using this data. For 20 boards, when X is 20, the total cost is going to be 6,000. So that's what you're using to find X, to find the swap. So you're going to subtract 400 in both sides. And you're going to get here 5,600 equals 20M, the swap, divide by 20. And that's going to be my swap. So we're going to divide 5,600 divided by 20 is 280. So my equation is going to be 280, that's the swap X, plus 400. Let me check that. Okay? Any questions on this? Okay, then you're gonna go, the next one, it says the average cost. So the average cost is pretty much, I was gonna show you in the slides. Average cost is this divided, they give you the formula here, so let's go with that. So the average cost is gonna be the cost function. So this is the average cost, is the cost divided by X. So what you need to do is get the cost function, 280X plus 400 divided by X. So put everything over X and simplify. X and X cancel. So it's going to be 280 plus 400 over X. That's your answer. That's what you're going to put there. And it's going to be 280 plus 400 over X, like that. Okay, so that's how you do the cost function, the average cost function. And then sketch the graph of the average cost function. Now, the average cost function, it's a fraction, it's a rational function. So you need to see which one of those is the graph. So here we're going to compare, we're going to find for this function, we're going to find for this function, we're going to find there's a horizontal asymptote. What is the horizontal asymptote? See, this is the fraction part, so don't worry about 280. 280 means it's going to move a little bit, but so it's going to actually, yeah, that's going to affect. So the horizontal asymptote and the vertical asymptote, that's what you need to compare to see which one of the graph is. So obviously the vertical is the bottom is not 0, so it's going to be X equals 0 is the vertical. And the horizontal, the 400 in the top, X in the bottom is going to be Y equals 0, because this is the first case. So which one has asymptote? X is 0 and Y is 0. Okay, because it's 280 plus, so that means you have to move it a little bit. Or you know what, when you need to combine it. Let's do that. Okay, so so you need to simplify this first before you do that. So this is over 1. That's gonna shift a little bit the graph. It's gonna move it a little up because of this 280. So you're going to multiply 280 by x, so it's going to be 280x plus 400 over x. So this is how the graph is, the equation of the function is going to look like. So the vertical asymptote is going to be x equals 0 from the bottom, but the horizontal is going to be different. So this 280 is going to affect the graph. How is going to affect it? Now it's going to be a second case because you have x in the top and x in the bottom. So the horizontal is going to be a over b, remember? So it's going to be 280 over 1. And now which one of those is 280? It looks like it's the first one, right? Because this is 500 is the scale in the y-axis. So 280 is right below 300, right? So I think it's the first one. Okay? So that's how you check which graph it is. So you have to find the average cost function, and you have to add those two. So be careful with that, okay? We need to add everything. We need to add those together to make it as a one fraction. And then from the bottom, you get the vertical. From the, if it's 1 over 1, you compare one of the three cases. This is going to give you the horizontal asymptote. Okay? So that's how you do those. And then I think you have one more like that. Let's see. Yes, it's, hold on. Okay, they asked me one more thing. What does the average cost per board tent reduction increase? So that means if x go to infinity, so you're going to go to 280 because that's your, you're going to put 280. Okay? Because the graph is going to go close to 280, right? See, looking at the graph, let me just explain that. So looking at the graph, when the production increase, so that means if the graph going to infinity, the graph is gonna, the average cost is gonna go close to this line, which is 280. Make sense? And then the last question is also the same one. So you have the cost function, you're going to divide by x, and it's going to give you the pretty much everything else. Okay?